This is lesson 7.4, subtract fractions with like denominators. It is found on pages 325 through 328 in your workbooks. So, I worked as a postman back in the day, but only for one day, because I looked at the first letter I was to deliver and I thought to myself, this isn't for me. My goodness. The good thing about it is that, it's a joke. I was never a postman at all. Moving along. So our learning target in this lesson will be to subtract fractions with like denominators. So in 7.3 we added. In this lesson we're going to subtract, and hopefully by the end you can do it on your own. Alrighty. On our look back, it wants us to shade to show each fraction. Alright, I'll go ahead and do it while you're doing it, and then you can make sure that yours and mine look alike. Alright, so it should look like that. And then in our look ahead, use the models to find each difference. So 3/5 and 1/5, so we got 3/5 and 1/5, so we'll mark out one of them from each one, and we're going to have 2/5. 4/6 and 3/6. Well, if I mark out 3 from here, mark out 3 from here, I'm going to have 1 left, so that's 1/6. And then 7/5 or 7/8 minus 5/8, so mark out 5 from each one, and I'm going to have 2/8 left. Right, in our I can statement there is I can use models to subtract fractions. Well, we need to write a rule for subtracting two fractions that have the same denominator, and it's going to be a lot like the one that we used in 7.3. Subtract the numerators and keep the denominators as they are in the difference. Alright, so we've subtracted the top numbers, kept the bottom numbers the same. Alright, so in our key concept, subtract fractions with like denominators, it says to subtract fractions with like denominators, subtract the numerators, the denominator stays the same. So they subtracted the numerators, 7 minus 3, we've got 4/8. What would that also be? Yeah, that would be 1/2, because they can both be divided by 4. Alright, and then our next example, find the difference of 1 minus 3/5. Wait a second, that's a whole number. How do we do that? Well, look, we're going to write 1 as 5/5, because we want it to have the same denominator, right? And we know that any number divided by itself is 1. So 5/5 is 1. So 5 minus 3, 5 minus 3 is 2, 2/5. Alright, let's do some in-class practice. I'm going to solve 1 and 2 with you, and then we will start the process. Alright, so 3 minus 1 is 2 over 2. That's going to equal 1. Alright, and then I'm going to have 12 over 12. Why 12 over 12, Mr. Paymer? Because there's my 12ths there. I want it to be the same denominator. So 12 minus 8 is 4/12, or 1/3. Alright, hey, number three can be a little confusing because it's 3 instead of just 1. So we can do two things. We can either have 9/3, because 9 divided by 3 is 3, or we can have 2 and 3/3. Either one will be fine, because what we can do here, 9 minus 2 is 7/3, or when we have 2 minus 2/3, we're going to have 2 and 1/3. And 7/3, when it is simplified, 7 divided by 3 is 2 with 1 remaining. So either one will work. All right, you go ahead and solve number 4, and then we'll go over it. All right, so we got 2/10, which can also equal 1/5 because both can be divided by 2. All right, you solve number 5, and then we'll go over it. 13 minus 7 is 6 over 6. That can also be 1. Number 6, solve that one, and we'll go over it. 4 minus 3 is 1. Keep my denominator. All right, number 7, solve that one, and we'll go over it. 60 minus 43 is 17 over 100, and that's already simplified. Oh, goodness. Number 8 is 11 over 2 minus 2. Well, check this out. 11 divided by 2 is going to be 5 and 1/2. Because 11 divided by 2, we got 5 and 1 remaining. So we're going to subtract 2. 5 minus 2 is 3 and 1/2. That's how we do it. So when you have a fraction like this, you can just make it into a mixed number. Now something else you could do also is change the 2 into an improper fraction, and we do that by doing this. So we want the same denominator. Well, 4 divided by 2 is 2, so that improper fraction is the same as 2. 11 minus 4 is 7/2, and 7 divided by 2 is 3, with 1 as a remainder. Alright, so we can do it either way. Whichever way is easier for you or more preferred to you is fine. Alright, let's go to number 9. Match each expression with a polygon that has a number of sides equal to the numerator of its difference. So let me show you the first one. So we got 8 minus 2. That's going to be 6/10. 6/10. Which one has 6? 1, 2, 3, 4, 5, 6. So boom, right here. That's what you're doing. All right, do the next 3, and then we'll go over it. 9 minus 1 is 8 over 10. I think it's this one. 1, 2, 3, 4, 5, 6, 7, 8. Boom. 7 minus 2 is 5 over 10. Got our pentagon. 8 minus 1 is 7 over 10. So 1, 2, 3, 4, 5, 6, 7 over 10. Alright, on 10, 11, and 12, we're finding which expression does not belong with the other 3. Go ahead, solve number 10, and then we'll go over it. Alright, so we get 2/8, 3/8, 3/8, sorry, 3/8 and 3/8. 2/8 doesn't belong. Solve number 11 and we'll go over it. 7 minus 2 is 5. 9 minus 4 is 5. 5 minus 0 is 5. 8 minus 4 is 4. So it's that one. Alright, number 12. Solve number 12 and we'll go over it. 8 minus 6 is 2. 5 minus 3 is 2. 6 minus 3 is 3. 4 minus 2 is 2. Alrighty. Number 13, we're going to find the missing number. So 9 minus something is 3. 9 minus something is 3. 9 minus something is 6. See, I got ahead of myself because 9 minus 3 is 6. Alright, go ahead, solve number 14 and we'll go over it. Alright, 7 minus 1 is 6. Alright, number 15, solve that one and we'll go over it. 4 minus 3 is 1. Alright, number 16, solve that one and we'll go over it. 7 minus 5 is 2. Alright, number 17 is matching. It wants us to match the pair of bottles whose difference is 1 over 8. Alright, so we need to find 1. Well, I'm going to do the first one for you. 7 minus 6 is 1. Alright, so just looking at those numerators, find the other pairs. Alright, Alright, so 4 minus 3 is 1. And then 1 minus 0 is 1. Alright, let's connect this to real life. So our test prep, a sailfish has completed 5/12 of its migration. What fraction of its migration does it have left to complete? So we're going to do 1 minus 5/12. So we can write 1 as 12/12 because we want it to have the same denominator. So we can do 12/12 minus 5/12 because 1 represents the whole migration. So 12 minus 5 is 7. So 7/12 right here. And 7/12 is close to 1/2 when they did their estimate. Alrighty. Well, I want you to read and solve number 18. Go ahead and do that, then we'll go over it. So a humpback whale has completed 3/10 of its migration. What fraction of its migration does it have left to complete? So 1 would be the whole migration, so 1 minus 3/10. Well, I'm going to write it as 10/10. Why? Because I want it to have the same denominator, and 10 over 10 is 1. Minus 3/10 is going to be 7/10. So 7/10 of its migration. Alright, let's go on to number 19. Go ahead and read and solve number 19, and then we'll go over it. A leatherback turtle has completed 2/5 of its migration. It stops to rest and feed. Then it completes 2/5 more. What fraction of its migration does it have left to complete? So we get 2/5. It goes 2/5 and then another 2/5. Well, that's going to be 4/5. Well, if 5/5 is its whole migration, and we subtract 4/5, it's going to have 1/5 left. So 1/5 of its migration. All right. Number 20 is a dig deeper. And I think this is a Jolly Rancher moment. So go ahead, read and solve number 20, then we'll go over it. A shark has completed 3/10 of its migration. Then it completes 3/10 more. Does the shark have less than 1/5 of its migration left? Explain. So we get 3/10 plus 3/10. That's going to equal 6/10. So if we take 10/10 and subtract 6/10, we're going to have 4/10 left over. And if I take 4/10 and divide them both by 2, it's going to be 2/5. So does it have less than 1/5 of its migration left? No. And I'm explaining that with my math because 2/5 is greater than 1/5. All right, hopefully you got that right and you got Jolly Rancher. Well, let's go back to our learning target here. Subtract fractions with like denominators. Hopefully you can do that. I can use model to subtract fractions. I can use a rule to subtract fractions. Hopefully you can do that. And of course, I love you. So if you're still in the number 2 and you can do it with help, I will gladly help. You just need to ask. And of course, as always, if you're a number 4, you have the opportunity, if you would like, to help your peers who are at a number 2 still. Well, all right. Y'all have a good day.